In April of 2025, China held the world's first humanoid robot half marathon, and I want you to really sit with what that means before we go any further. Multiple humanoid robots from multiple different Chinese companies lined up on a track in Beijing and ran 21 kilometers on two legs by themselves, without cables, without remote operators, without a safety crew running alongside them. The winner crossed the finish line in 2 hours and 40 minutes, and the crowd watching wasn't made up of futurists or science fiction enthusiasts. It was engineers, government officials, and investors who already knew this was coming, because they had been watching China's humanoid robotics industry build toward this moment for years. And what makes this significant is that the race wasn't any single company's achievement. It was a demonstration of an entire ecosystem that has been quietly built from the ground up, and today we're going to walk through that ecosystem together, because the machines that came out of it are genuinely unlike anything the world has seen before. If this is the kind of story you love, go ahead and hit that like button and subscribe, because we cover exactly these kinds of shifts, the ones most people don't notice until they're already everywhere. Before we get into the specific robots, it's worth spending a couple of minutes on why this is all happening now, because the timing isn't a coincidence. Industrial robots have been around since the 1960s, but they've always been bolted to a single point on a factory floor doing one fixed task, because moving through the real world on two legs is one of the hardest engineering problems that exists. The human body took millions of years of evolution to get walking right, and replicating that in hardware has been frustratingly difficult for decades. What changed recently is three separate things converging at almost exactly the same time. First, the motors that power a robot's joints, called actuators, got dramatically cheaper and more powerful, largely because China's electric vehicle industry had already built a massive supply chain of high-performance motor manufacturing, and that same supply chain turned out to be directly useful for humanoid robotics. Second, engineers figured out that instead of manually programming every movement a robot needs to make, you could train it in a digital simulation, letting it accumulate the equivalent of millions of hours of practice in a virtual environment, and then transfer those learned behaviors into a physical body. A process called sim to real, which collapsed the time needed to teach a robot something new from months down to days. And third, AI chips became small enough and power efficient enough to fit inside a robot's body and run real-time decision-making without needing to be connected to a distant computer. All three of those shifts happened in close succession, and China, which had been building toward this through deliberate national policy, manufacturing scale, and a deep pool of robotics engineers, was set up better than anywhere else to capture the moment. So let's go through the machines that came out of it, starting with the one that made most of the world stop and do a double take for the first time. The first robot on our list is the Unitree G1, and the thing that hits people hardest when they first hear about it isn't what it can do, even though what it can do is remarkable. It's what it costs. The Unitree G1 starts at $16,000. That is the price of a humanoid robot that can do continuous backflips, execute kung fu sequences with controlled fluid weight transfer, perform synchronized dance routines in front of hundreds of millions of viewers at the Spring Festival Gala, and walk across a snowfield in minus 47 degrees Celsius temperatures for 130,000 steps to prove its cold weather reliability. To understand why that price is so shocking, the previous benchmark for an affordable research robot was Boston Dynamics Spot, a four-legged machine that doesn't even have arms, and that costs around $75,000. The G1 stands 132 centimeters tall, weighs about 35 kilograms, and has between 23 and 43 degrees of freedom depending on which configuration you order, which means it has an enormous range of motion across its joints. It walks at 2 meters per second, carries a 3-finger dexterous hand with force sensing built in so it can actually feel what it's gripping rather than just clamping blindly, and its sensor package includes both a 3D LiDAR and an Intel RealSense depth camera. In early 2026, Unitree went further and open-sourced a model called Unifo LM VLA 0, a vision language action system that lets the G1 accept plain language instructions and work out for itself how to carry them out physically, without needing a programmer to pre-specify every step. Beyond all of that, Unitree filed for a $610 million IPO in March 2026, backed by 335% year-over-year revenue growth in 2025. And a newer model in their lineup called the R1 launched in July 2025 at just $5,900. In 2024, analysts said a sub-$10,000 humanoid robot was probably 5 years away. It arrived in about 12 months. And as impressive as the G1 is, Unitree actually has a second robot in this lineup that tells a completely different part of the story. And this one is about raw speed in a way that genuinely doesn't feel real until you see the numbers. That robot is the Unitree H1. And where the G1 is about making humanoid robots accessible, the H1 is about making the rest of the world understand how fast this technology is actually moving. The H1 is a full-size humanoid, standing 180 centimeters tall and built entirely from components that Unitree designs and manufactures in-house, from the motors to the actuators to the control systems, which is the thing that gives them both a cost advantage and a performance ceiling that most competitors can't match without rebuilding their entire supply chain. In March 2024, the H1's V3.0 Evolution version set a Guinness World Record for the fastest full-size humanoid robot on a flat surface, hitting 3.3 meters per second, which is 7.38 miles an hour. The previous record belonged to Boston Dynamics Atlas at 2.5 meters per second. By April of 2026, Unitree released footage of the H1 on an athletics track reaching a sprint speed of 10.1 meters per second. For context on what that number actually means, Usain Bolt's 100-meter world record averages out to about 10.44 meters per second across the full race. The H1 is testing at 10.1 at its peak, and Unitree's CEO has publicly said he expects a humanoid robot to complete the 100-meter dash in under 10 seconds within the next few years. Beyond the speed records, what makes the H1 strategically important is that it's available for purchase right now at around $90,000, and it represents the majority of why Unitree shipped around 5,500 humanoid robots in 2025, which was roughly 1/3 of the entire global humanoid robot market that year. Tesla's Optimus, which is frequently cited as the main competition, shipped approximately 150 units in the same period. One Chinese company from Hangzhou delivered more humanoid robots than the rest of the world combined. Now, speed records and affordability are one dimension of this story. But what a lot of people in the industry will tell you is that the hardest challenge in humanoid robotics isn't making a robot that's fast or cheap. It's making one that's actually useful inside a real factory. And that's where the next company on this list has done something that most people in the industry didn't expect to see this soon. That company is UB Tech, based in Shenzhen. And their Walker series of industrial humanoids has crossed a threshold that most of the robots we've talked about so far haven't reached yet. They've actually been deployed at scale in working factories, doing real jobs on live production lines alongside human workers. The Walker S, the first version deployed commercially, went into NIO's advanced manufacturing facility and was documented as the world's first instance of a humanoid robot collaborating with human workers on an active automotive assembly line. It wasn't doing a demo in a cordoned-off section of the plant. It was performing quality inspections on moving vehicles, checking door locks, verifying headlight alignment, measuring fluid levels, and confirming panel fit to a standard of accuracy that the company says exceeded 99%. It was also installing trim components and vehicle badges, and moving parts between stations independently. From NIO, the Walker series moved into BYD's manufacturing operations, where Walker S1 handled material logistics in coordination with autonomous ground vehicles, completing what UB Tech described as the world's first integrated humanoid plus autonomous logistics deployment in a factory environment. All of that real-world operational data fed directly into the Walker S2, the upgraded model that went into mass production in November 2025 and is the current version being scaled commercially. The S2 stands 176 centimeters tall, has 52 degrees of freedom, carries up to 15 kilograms per arm, uses 4th-generation 5-finger dexterous hands rated for sub-millimeter precision, and has force-compliant joints throughout that sense, unexpected resistance and adjust rather than pushing through, which is what makes it safe to work physically alongside human beings. The feature that sets it apart from everything else in the industrial space is that it can swap its own battery in 3 minutes without any human assistant, walking itself to an exchange station, removing the depleted pack, installing a fresh one, and going straight back to work. That enables the kind of continuous 24-hour operation that an organization paying over $100K per unit actually needs to justify the investment. By late 2025, UBTech's order book for the Walker series had crossed 800 million yuan, around $112 million, with individual contracts from Foxconn, Geely, FA Volkswagen, Audi FA, Bayek New Energy, and the logistics company SF Express. The Walker S2 has proven that humanoid robots aren't just a research curiosity anymore. They're a procurement decision. But while UBTech's story is about industrial deployment, the next robot on this list made its reputation doing something entirely different. And it's the one that robotics engineers themselves tend to bring up when they talk about what great humanoid locomotion actually looks like. That robot is the Engine AI PM01, and it was built by a company called Engine AI that was only founded in October 2023, which should give you a sense of how fast things are moving in this space. The thing that defines the PM01 isn't strength, it isn't speed, and it isn't price, even though the price at around $12,000 undercuts the Unitree G1. What defines the PM01 is the quality of its walking gait, and specifically the fact that when most people see it walking through the streets of Shenzhen for the first time, their immediate reaction is confusion about whether they're watching a robot or a person in an unusual outfit. The way it walks, the stride length, the arm swing, the posture transfer from step to step is close enough to natural human movement that it produces a genuine double-take response in people who weren't expecting it. Engine AI achieved this through what they call an end-to-end neural network gait optimization system, which means rather than programming specific movements for specific situations and building a library of responses, they trained a neural network to produce natural gait as a continuous real-time output, adapting moment to moment to whatever the terrain, load, and environment happen to be. In the same way your own body makes thousands of tiny invisible corrections when you walk without you ever consciously thinking about it. The PM01 is 138 centimeters tall, weighs about 40 kilograms, has 24 degrees of freedom including a 320-degree rotating waist that most competing platforms at this price can't match, and runs on a dual-processor architecture pairing an Intel N97 with an NVIDIA Jetson Orin for onboard AI inference. It's fully open source, compatible with Isaac Sim, Mujoko, and Rose, and priced to be accessible to developers and research teams rather than just well-funded institutions. In 2025, PM01 units were used in police patrol demonstrations on the streets of Shenzhen, where the robot's ability to move through a pedestrian environment without making people recoil from its presence was the entire point of the exercise. Engine AI launched 3 separate humanoid models in the 6 months between July and December of 2024, a pace of product development that most established robotics labs with years of experience couldn't match. The PM01 is the product that got them global attention, and it did it by solving the problem that in some ways is the hardest one of all, because without natural movement, none of the other capabilities matter very much in the environments where these robots actually need to function.